Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Seamless data integration into AI applications often falls short, leading many to adopt RAG methods, which come with high costs, complexity, and limited scalability. Cogni offers a better solution with its open-source semantic memory engine that automates data ingestion and storage, creating dynamic knowledge graphs from your data. Cogni enables AI agents to understand the meaning of your data, resulting in accurate responses at a lower cost. Take full control of your data in LLM apps without unnecessary overhead. Visit aiengineeringpodcast.com/cogni, that's COGNEE, today to learn more and elevate your AI apps and agents. Your host is Tobias Macy, and today I'm interviewing Ali Golshan about the role of synthetic data in building, scaling, and improving AI systems. So, Ali, for people who haven't heard your previous experience, can you give a brief introduction?
Yeah, sure. Thanks for having me. So I am one of the co-founders at Gretel.ai. I'm the CEO. Prior to Gretel, I was the CTO co-founder for another startup. We focused on the infrastructure and security space, a company named StackRox. We worked on managing and scaling Kubernetes infrastructure for various workloads. The predominant one we started to see was around data engineering and machine learning. That company was eventually acquired by IBM Red Hat. Prior to that, I had another security startup I was the CTO co-founder for, named Cyfort. We focused on endpoint security analytics, so keeping end users safe and secure. That company was eventually acquired as well. And prior to that, I started my work in government intelligence agencies, mostly as a data and infosec and signals intelligence analyst on a variety of different types of projects, mostly related to privacy of data and cybersecurity.
And do you remember how you first got started working in the ML and AI space?
Yeah, so my entire career has had one consistent theme, which was hyperscale environments with a lot of data. So in most of the use cases that I have built around as a developer engineer, and then eventually sort of was more of an entrepreneur, they've all required some massive data processing requirements, and machine learning just happened to be one of the predominant drivers behind what we used. It sort of all started with big data analytics, the whole term, and the rise of Hadoop and so forth. But I would say just because data has been an integral part of everything I've done as far as work goes, processing and sort of feature engineering that data at scale was something that was just embedded into all my work. And at Gretel, we decided why not just focus on that part of it.
And so synthetic data is definitely a core piece of what you're doing at Gretel. But before we dig too much into that, I'm wondering if you could just start by summarizing and framing what we even mean by the term synthetic data, because it can mean a few different things, from I just cat dev null into a file somewhere to somebody who manually generates a bunch of stuff, and just wondering if we can set the framing of the conversation.
Yeah. Synthetic data as a concept and as a term is not new. It's been around for a good decade and a half. I think it really comes down to how you produce that data, to your point, which sort of frames our conversation. So what we focus on is our view of synthetic data is something that is purpose-built for AI use cases. Now, what does that mean? It means the quality, the deep structural stability, the privacy and safety of the data has to be incredibly high, but at the same time, it can create additional friction or sort of workflow issues for users. In that context, as we talked about, there's sort of different approaches to it. Sort of there's traditional ways of dealing with synthetic data, which was basically just generating large volumes of sort of fake data. One area that was very useful is like test data management, QA and test. Like I'm just trying to test a pre-production service and I need lots and lots of volume so I can simulate some event, and that's all I need. There's sort of another component that has become pretty dominant in the narrative, which is really how, let's call it like frontier model companies or large language model companies talk about synthetic data, which is taking a model and having a large language model generate high quality data for training or fine tuning another model. And we've seen this in the industry on a number of different areas. And This is also why you're starting to see, proprietary and open source companies have different policies and terms of agreement when it comes to the usage of data from those models. Our view is that our goal is really to help enable organizations and enterprises to use the data they have or get started with data they need but don't have enough of it. So the way we approach it and sort of our view of synthetic data is our customers have typically one of two bottlenecks when it comes to data. I have the data I want to use, but because of safety, privacy, compliance, regulation, sensitivity, I can't use it and give access to my users or use third-party infrastructure, or use it for fine-tuning and customization of models. So we take a privacy-enhanced approach to how we generate synthetic data from your data being the core seed input into it. And then there's another category which we can sort of expand on, which is, as an example, I'm trying to improve this large language model's ability to translate text to SQL code, or generally text to source code. Large language models are not good for natural language to code generation translation. So that is a type of use case where an enterprise might be trying to, for example, build a very specific capability into a model and they just don't have the data. So that's what we mean by synthetic data, is essentially addressing those two data bottleneck problems.
As you mentioned, the whole idea and use cases around synthetic data have been around for a number of years now. And I'm wondering if you can talk to some of the ways that the capabilities around the actual creation and the quality and validation of those synthetic data sets have changed across the I guess boundary layer of pre and post LLMs, because there's
Sure.
definitely a pretty substantial shift in the capabilities and use cases and the overall technique of actually generating that synthetic data.
Yeah, absolutely. So let's call it sort of pre-LLM and post-LLM, or not even LLM, just language models versus non-language models. Also partially because like when we started, we were the only company that started building synthetic data using language models, but we weren't even using LLMs. We were actually using LSTM in 2020 when we got started, before sort of the LLMs became popular. But before language models, really the approach was using GANs, or statistical models. So like a graph-based model. And the power there is they were very fast, they were efficient. You can even run some of them on CPUs. You didn't need GPUs. But what those models do, and this is where sort of almost all other synthetic data companies started and build their products from, is those types of synthetic data models and approaches are very good at finding the shape, the distribution, some insights into your data, but they are not good at sort of putting together the deep structural stability, like the ripple effects that are caused if you move one variable, what happens somewhere else. So like if you have a shape in the distribution of the data, you can increase one variable in your data. But the model, if it knows the shape and the distribution, doesn't know what other aspects or underlying components will be impacted. So it turns out this is actually what language models are great at, is understanding that deep structural stability, that prediction of influence and impact, and sort of next token prediction is phenomenal for understanding in synthetic data, not only what is my data saying, but this is actually, we hear this quite often, is that if I use a language model, I can address use cases that one of our customers calls what if scenarios. Like, what if I had more of this? What if I had more of that? What if this happened in my data? So you can actually change non-arbitrarily the shape and distributions of your data. So what I would say is that the big change in synthetic data with language models was going from being able to make predictions on previous data sets and doing something with it that is more, call it rudimentary, maybe machine learning and feature engineering, to being able to actually augment real data and making predictions and using it for generative use cases in AI. And I think that's the tipping point that language models created for us.
In terms of the actual motivating factors for synthetic data, you mentioned a few of them, but I'm curious if you can talk to also maybe some of the ways that the purpose of synthetic data and its application has changed across that pre-LLM or post-LLM
Yeah.
epoch.
Yeah. So there's a few things. One is, one of the things we did very early on, we actually ended up pioneering this approach, was the application of differential privacy techniques to language model training at training time. What this enabled was not only the synthetic data, but for the model itself to ensure it is safe, private, and it's not memorizing any secrets. The reason that became very valuable is one approach here is companies who are trying to take data and extract all of its insights without its attributions and teach a model about it. So a good example here is like the analogy we use is that in healthcare, one approach of privacy techniques to synthetic data enables you to teach models about the disease, not the patient. So that's ultimately one sort of massive breakthrough in some of the new techniques of differential privacy and synthetic data, which is that we can now finally teach these models about insights about us, but not teach them about us specifically. I think that's a very important distinction. Sort of our view is like we need to put all our private and sensitive knowledge into these models, but not teach these models about us personally. So that's one big area. That's, again, where language models have been pioneering. The other part of it is we do fundamentally think that data is the bottleneck for AI to take sort of generational jumps forward. If you think about the last 4 or 5 years, it has been building these massive frontier models on large volumes of public domain, messy, privacy-riddled data. The next 10 to 20 years, as we're thinking about smaller language models, agentic approaches, more of sort of compound AI systems, it's about incredibly domain-specific or task-specific data that can customize a small model to perform incremental or perform highly specialized tasks in collaboration with other models. So what synthetic data is very good at, and there's a really great paper around this from Microsoft, which is called Textbooks Are All You Need. It describes, and this is sort of the core philosophy of our approach, is synthetic data has the ability to communicate knowledge from data the way a textbook does, not a way like a Twitter post does. So what that means is you can use an order magnitude less data to train a model 1/5 to 1/8 of the size. And we have some examples of this with the work we did, for example, with Databricks, and still end up with double-digit improvements comparable. So you're improving how much data, the size of the model, as a result, the inference cost, the total data set. This means you can build much smaller and much more specialized models that in collaboration can perform significantly better. And in ways, when you start to then introduce techniques like reflection into them as part of an agentic system, you can have systems that generate just from a prompt or from a conversational AI interaction. They can synchronously generate domain-specific data for you just so you can get started. And that's sort of one of the goals we have is that ultimately, if you're a builder, developer, researcher, you can experiment with hardware configuration, architecture, GPUs, code. But experimenting with data is incredibly slow, expensive, time inefficient. Like working with data is 5 orders of magnitude slower than working with code. If you can take a few orders of magnitude off and make that more of a life cycle, sort of a flywheel life cycle, then acceleration and adoption, we think, will really sort of improve across AI as well.
For teams who are embarking down the path of incorporating synthetic data into their overall AI system development and deployment strategies, what are some of the typical techniques that they'll reach for first, and maybe some of the edge cases or shortcomings that they'll run into as they try to scale from initial prototype of, hey, this looks like it kind of works, to now I need to run this at scale for production use cases where I have continuous data needs?
Yeah. One of the common friction points we come across in the market also has to do with the fact that the market in itself is very nascent. So when you're doing, for example, synthetic data the traditional way, I'm doing QA and test, I'm doing test data management, I'm just redacting or, removing PII, I'm not actually, making the data differentially private. What you're doing at that point is you're looking at a large corpus of data. So you're looking, let's say, at a lake house or a data warehouse you have, and you say, I just want to make that data synthetic because then I can just push it and test with it and do all these experiments. And that's all good and well. However, when you're getting into the sort of the use cases you're talking about, especially when you're talking about alignment with AI use cases, especially at scale, in these types of scenarios, when you have, for example, you're a financial institution and you're trying to improve fraud detection, or you are in a healthcare industry and you're trying to use EHR data to predict hospital stays and patient stays in ERs, you're not taking your entire corpus of data and just synthesizing it and using it again. At that point, what you are doing is you're taking your data and you are synthesizing it for a very particular use case. So what you want in some cases is you might want to highlight and actually improve and increase the diversity distribution of what fraud looks like in your data, because that's the signal you're looking for. Or you are looking, for example, for very specific indicators that help you make better inference point decisions. So the point being is that in sort of traditional use cases, when you were going lower level environments, you just took all your data and you made it synthetic and you used it almost the same way. Now that you're trying to sort of go up and more into production and make forecasts and predictions, the data you transform and synthesize has to be synthesized for a very particular use case, which means how that pipeline generates the data, the configuration that tunes the epochs you run, for example, the privacy, quality, and evaluation data sets you generate to measure it, all look very different. So it's almost like the input might be your data, but the output is specialized, customized data for the use case you're trying to improve.
For that use case perspective, I think another interesting challenge is when you're dealing with domains where you need very specific factual grounding for that information. I'm thinking in terms of things like scientific or educational domains where you want to provide some reliable data as the input to something like a RAG system that an end user is then going to interact with in a maybe a tutor oriented or an educational context of they want to be able to learn more, understand more about that specific domain. So you want to make sure that the data you're feeding into it has an appropriate grounding. And I'm wondering, is that a situation where you just can't use synthetic data, or just some of the ways that you need to think about the ways that the synthetic data is applied or sourced for being able to feed into those particular types of domains?
There are a lot of answers there. So maybe just sort of breaking the question apart a little bit is the problem you're stating is very real in synthetic data, and it's actually where originally synthetic data really struggled, because a lot of the traditional synthetic data models are what we call random weight models, not pre-trained models. So the first time they were learning about the data, they were learning on your data, so they had no context of the larger world. This is also where sort of most synthetic data companies came from. That was problematic because what good or bad looks like in that specific domain data was not very, sort of apparent. Language models improve that, because if you ask a large language model, like this is health data, or talk to me like a financial advisor, or now talk to me like a radiologist, it has some basic understanding of what that means. But ultimately, this is where, sort of our view is that the way you solve that is not at the model level. The way you solve that is using compound AI architecture. So you have multiple models that have very special domain expertise. But there are just some cases where synthetic data is also just another tool, right? It's not for everything. And the use case I would say is that if you, for example, are using synthetic data, you have to make a decision between utility and privacy. If you want mathematically provable privacy, it means the data you generate can never be reversed back to an individual. That also means if you're doing, for example, drug trials, and you have individuals in the trial, if you synthesize their data, you never know who the original person was. So you can't rehydrate the data. So some of those types of use cases are not a good fit for synthetic data that is, mathematically provably safe. Now, in the case of some domain-specific work, what we have found is there is no sort of silver bullet, but then sometimes you have the opportunity, like we did this with a company named Illumina in the genomic space, where they do a lot of work in genotype and phenotypes. And we work with them, and based on sort of open data sets that they had and large volumes of non-sensitive data they had, we could fine-tune models that understood better what genotypes and phenotypes mean in a language model. At the end of the day, no sort of standard generic model is going to be perfect. This is where we do think there is some level of customization with the company's own data needs to be done. And the way to do that is you need to ensure that that is being done in a safe way. So the data going into it is not memorized, it's not raw data, it's not just redacted or anonymized. Like there are differentially private guarantees. But this is where I would say the market is still somewhat fragmented as to like what is it that you're trying to accomplish, and then sort of take the associated approach.
Digging a bit more into that architectural question, from a naive perspective, the way that I would think about synthetic data generation is, okay, I need to populate a bunch of data for this one use case. I'm going to click the button and say, this is how much data I need. it spews it out into some sort of file format, and then I go on my merry way and do whatever downstream work needs to happen. And I'm wondering if you could just talk to some of the ways that the overall life cycle of synthetic data is managed and some of the methods for being able to integrate it more closely into the overall engineering life cycle of AI applications and AI model development or fine tuning or agentic structures.
Yeah. What you're describing is certainly one of the flows that exist in synthetic data. That particular workflow we tend to see more when it's companies or users who are doing more experimentation work. So one-offs, trying to validate something, proof of concept, test something, things like that. The sort of the other side of it where most of our focus is in this model where we call always on. Basically, I just need data all the time for whatever my use case is. And these are typically more production or, trying to move towards serving the model, not just training the model. In those particular cases, there's a few things that we've tried to do. And our view is like synthetic data is just data, right? So what you don't want is another layer into the existing builder, developers, workflow, researchers workflow that they have to go sort of request data. So the approach we've taken is on one end, build all these native connectors to things like BigQuery and Microsoft Azure Fabric and S3 and Redshift and Snowflake and Databricks' various solutions, where the builders one time integrate us into that source. And then they can run schedules or build entire workflows that says once a day, once a week, once a month, I want to take this type of data at this time, synthesize it and pump it into this system. And the output of that could be directly basically then fed into things like SageMaker or Azure OpenAI or Vertex for model fine tuning. And eventually that model can then just go into like something like a Mass or Bedrock and just be served. But the way we think about it is that what are all the touch points that sort of a builder needs from the moment they request the data to fine tune a model or customize a model to then generate data to measure the sort of the capabilities of the model, to then measure the gaps and regenerate data, and how do those injection points happen and just make those a natural part of the overall process. So very much like an SDK API integrations into the building development workflow for builders, rather than breaking their flow and saying like, here's something manually you do, download it to a file, and then you sort of take action on it.
From a scaling perspective, as you're going to that production use case, what are some of the challenges or complexities that are not at first obvious when you're first starting with, I'm prototyping, I'll generate a bunch of data, whether it's using Gretel or a faker script in Python or something, and then saying, now I actually need to run it at production scale, and just some of the validation and quality checks that you need to be thinking about to make sure that you have an appropriate distribution, but not necessarily a lot of duplication, or that the values are, within appropriate ranges or actually are sensical and you're not just spewing gibberish into it.
Yeah. There's quite a bit to think through. I mean, I think nobody would argue that operationalization of AI tools is by far the most challenging part of it. And I would even go as far as say, like, most can probably do some of the things they claim. It's just actually being able to run them in an effective environment that is the most difficult part of it. And the reason is that like we, Gretel, are one part of this, right? But for a synthetic data tool to be effective, to be perceived valuable, and then to deliver value, you have to have a relatively mature platform for how you manage your data, to your ML ops, to your fine tuning, to your serving. So you have to have some of that infrastructure in place. So what we have typically found is the scale part or the operationalization, some part of the system that they are building, let's call it these like AI specific applications or integrating AI into these new services, have a reliance on some either traditional system that doesn't support them or has certain infrastructure requirements that they cannot meet. Or as an example, like the data resides on-prem, but they're trying to use a cloud provider's managed stack for it, and migrating that data is the complexity. So what you find is that in very small scales, proving something is much more achievable. It's all the edge cases that really arise from it. Like in some cases, it might be that you can't even get, for example, like reserve instance GPUs, and as a result, you just can't process something. Like we've come across that for some larger companies. So the problems vary. I would say, though, in a lot of the cases, what we see are pretty common patterns, and those patterns do tie somewhat to the fact that there hasn't been a lot of consolidation, maturity, and growing in the infrastructure and the enterprise readiness of how people operationalize AI right now.
In terms of the effect of synthetic data on model performance, there's also the question of, well, if I'm just sending a bunch of random data into it, eventually I'm going to start cycling through the same values and the model is just going to start getting dumber. Or if I'm using the model to feed, using the synthetic data to feed into the model, then it's going to start drifting in terms of its understanding of the world, because that maybe the random data doesn't have enough contextual grounding for that fact-based or evidence-based use case. I'm wondering some of the ways that you think about mitigating that in terms of the use and judicious application of synthetic data versus mixing in real-world values to make sure that there's an appropriate balance between the synthetic versus the naturally generated data sets.
Yeah. There are a number of different techniques you can take. I can sort of focus on some of the things we do just because I'm more familiar with them. So one is, almost at the core premise of Gretel, which is we focused a lot of our efforts on privacy in large language model and small language model fine tuning and training. The reason for that is our view is if you're going to keep generating more and more synthetic data, you need, and we are enterprise focused. So that's sort of an important part of this qualifier for this answer is our view is you have to, as an enterprise or an organization, use some of your sensitive data to act as guardrails and seeds for how we generate more synthetic data. So we can't just start from absolutely nothing, unless, again, it's like I am trying to improve the SQL coding capabilities of this model. That's different. But if it's that I am a radiology company and I need X, Y, and Z to be represented in my data, then we have taken approaches where we can use your data safely as a seed and guardrails and then use that to scale. Now, so then the question becomes, okay, well, how do you scale that and not repeat itself? There are techniques such as reflection that we talked about, now some advancement of that into cognition techniques, which enable then the models to further reason. And actually what they do is this enables, when you're using a compound AI system, to increase diversity of data generation, not arbitrarily on the edges. So you get more diversity as you scale the data, ensuring you just don't end up with this fat middle thing. And then the last part of it is, this is where we think just at the same time, evaluation is a big part of it. Like right now, there's a lot of evaluation metrics and frameworks, and a lot of them, quite frankly, are just very biased or one-sided or just validate one thing or another. So there's an enormous amount of space to be built into there. We're trying to do some work just to sort of be able to validate some of our own work. But I would say those are the three pieces, really comprehensive approach to evaluation of the output of the data, especially around utility, using techniques like reflection, migrating into things like cognition techniques, and then using privacy techniques like differential privacy to use your data. Like those things used in combination tend to then improve that ability. But yeah, I don't think you can just take, a 500 billion parameter large language model, just keep generating data over and over again and just prompt tuning it just so you can get good data. Like there will be some catastrophic collapse at some point.
On the other end of the spectrum of maybe I'm just trying to prove out the idea for some AI use case. I have my model, but I have no data. So you've got the cold start problem of I can't gather data because I don't have anything to run to actually generate data naturally. And so I'm just wondering some of the ways to be thinking about the application of synthetic data in that use case for just prototyping and proving out an idea or bootstrapping some product that you want to eventually have be a production use case.
Yeah. So this is actually sort of the second problem we solve. It's our core platform helps do this. It's a product we have called Navigator, where it generates for you sort of synchronous small data sets and then asynchronously large data sets just from a prompt or conversational. I need EHR data and I need to have these fields or these columns. I need it to look and sound like this, especially in tabular format. And that under the hood is actually our compound AI system. It's a number of small language models that we have fine-tuned on particular domains or specific tasks that in sort of working in collaboration then can give you data if you have the cold start problem. Now, that data is never going to be 100% good enough. It's probably like 80 to 90% good enough, but it is certainly quality of data is where you can build an application where you can POC it, you can validate theses. Does this work? Will it run? Will it scale? And then be able to really sort of accelerate your process. Where that data is good enough, and in some cases even better than raw data, is if you're trying to improve what we call system level capabilities. So the model to write code, to speak to an API, to be able to write more declarative functions. Those areas, like the work we did, for example, with Databricks, we demonstrated that we can actually improve the model's capabilities by 60% in 4 weeks just by generating synthetic data from essentially an expert prompt into our agentic system. So again, these are all sort of improving fields. Like I think the most promising thing is not to say that all these things are ready for sort of showtime and at scale and sort of expected utilities. I think the good news and the most promising part for us is we are seeing month to month significant improvements on the outcomes of all these techniques and the applications of these techniques, because everything is sort of getting better across the board.
So digging a bit more into the work that you're doing at Gretel, I'm wondering if you can talk to some of the ways that you've thought about the system design and architecture design of what you're building, and some of the ways that you have to plan for evolution and adaptation as the ecosystem around you continues to grow and proliferate and become fractal.
Yeah. Yeah. Feels like every 3 to 6 months there's some massive shift under your feet and you have to adapt to it. There were a number of decisions we made early on, and then there were a few along the way that we made that have all been sort of in the pursuit of making the company as anti-fragile as possible. And some of those things are, like first principles, we didn't want to be a model company. We actually always viewed models to be either something that we could commoditize or will potentially open source will catch up enough that it will be good enough. So what we decided to do was focus more on the system architecture or system design versus the model. So this is where our bet was that if we, this was agents and chains before they just called them agentic systems, but our view was that if we can basically have a system where we can use any model and we can fine tune that model quickly and we can replace that model very quickly, we will never be reliant on a model. Because what we didn't want is one day a company showing up with this massively powerful model and just leapfrogging us as a company. So what we did is that one, we invested very heavily into privacy techniques. So if we use any model, we can have that model talk to your data in a safe way. The other thing we focus very heavily on is under the hood from an engineering standpoint. We build infrastructure that allows us to grab models, fine tune them, test them, generate data, and then retest them to a point that in the last 18 months, we've gone from about being able to run 4 to 5 of these experiments per week now to over 100. So that velocity means we can, at any point, we have an automated system that looks for a best of breed of that model, the newest version or a comparable version, brings it down, compares it against ones we have, fine tunes it, measures its outcome. If it's better, it replaces it. So, and then we offer these things called model suites where a customer can say, I'm just trying to test something. So if I'm using, call it OpenAI models under the hood is fine. Otherwise, they might say, well, I need an Apache license because I want the data to be used for building purposes. So we've also tried to make it very simple when you're using our system to understand that you own and can do what with the outcome data. Like, can I train another model with this? Or is this something I can just use for experimentation? And then the final thing we bet on was from very early on, because we didn't want to be a model company, is multimodality. Our view was that, especially when you look at enterprises, data gets very messy, very fragmented, and typically data in large volumes becomes in tabular form, but it has underlying time series components. It might have free text or unstructured text. If you go into health and finance, there's images attached to those. So multimodality was a big part of this. So I would say sort of everything we have done to make design decisions in the company sound and long term have been built on system design that enables us to use any model and very quickly, and privacy techniques that allow us to touch your data so we can use it as context. And those two things merged sort of expand the ecosystem of things we can work with. Now, some of the things that become challenging, like for us, is the operationalization part. So how do we natively fit into all the cloud providers, platforms, and data platforms, and every emerging AI tools ecosystem that a customer wants to work with? That's a little bit more complex in a sense that it's not difficult work. It's just a lot of volume of work and it requires some maturity. So you have very little control over it. But everybody's fighting that fight right now.
To the point, too, you mentioned multimodality. Another thing that we didn't really discuss yet is the structure and format of the data being generated and some of the ways that you need to be thinking about that as you're planning what data do I need, what shape does it need to be in, and how do I need to then process it to be able to have it ready for use in these different AI contexts where maybe a lot of that is generating an embedding of that text data or just some of the variations of structured versus semi-structured versus unstructured data generation that you need to be thinking about for the different use cases of AI applications.
Yeah. At the highest level, when we sort of started the conversation at Gretel, we were trying to back into certain use cases and the things we were good at and language models were good at. So naturally, when we initially thought about the limited scope of modality, we thought about it in essentially categorical, numerical, sort of free text type thing. So obviously, free text, natural language is one part of it. But then you can't really just focus on that. So this is where tabular modality, time series, relational were other things we brought in because they're sort of compound value add. The way the data gets stored is all sort of numerical or categorical in these environments. It's just the shape and the structure of them that changes. When you then take steps towards, for example, like image or audio or video, then you're talking about entirely new models that are built for that. And it's the interoperability that makes it a little bit more difficult. So the decisions we've made on those is what are modalities that have compound value add for us. So when we look at some of our core sectors, automotive, robotics, finance, health, gaming, while things like tabular, unstructured free text, time series, relational are important, the next sort of critical thing we saw was image. So we have an image synthetic that's in beta that's going to be G8 soon. Those go hand in hand. So like a radiologist has unstructured doctor's notes with a bunch of tabular data about a patient and actually like an imagery work. And if they want to do large scale sort of analysis on these, all that has to be synthesized. We're still in the process of sort of trying to figure out how audio video fits into these. We don't even know if those are sort of capabilities that at this early of a stage you can mix all under one, especially because we unlike a chat gpt or a Gemini, we're not consumer facing. So the way we think about modality is purely in the context of enterprises, not in the context of how an individual consumer uses our product.
And in your work of building Gretel, working in this ecosystem of synthetic data generation with a focus on these ML and AI use cases, what are some of the most interesting or innovative or unexpected ways that you've seen that capability applied?
Yeah, there were some really crazy ones, especially in like 2021, 2022-ish, when the crypto industry was taking off and they just had infinite amounts of money and they just thought, every tool could solve their use cases. So they just turned out to be some really, really dumb ones I won't get into. But some of the most interesting ones that we think are actually valuable. Like as an example, we work with Government of Australia's health system. And one of the most interesting things that we saw that they're implementing now using differentially private synthetic data is they have physicians that work in hospitals, but because of their regulations and policies, only have data that is accessible within that hospital. They couldn't go across hospitals. But what they didn't want is to give the doctor a snowflake environment and go query it. So what they wanted to do was actually have a large language model build it like an AI assistant that can talk to all the data and the physician can just ask it questions. So they're using us to create differentially private versions of synthetic data from all the hospital systems and then use that corpus to train the model on. So when a physician asks the question now, instead of handfuls of data samples, they have hundreds of data samples. And at the same time, if they don't have the expertise to solve for the problem they're trying to do, they can take a synthetic version of that data and work with research institutes or academia institutions who might have postdoctoral researchers focusing on that to get better results. So synthetic data in health, we think, has enormous capabilities and reach. Some of the other ones we've seen that is super interesting are companies that are looking to build AI agents for users on the endpoint, but the companies that we're working with don't want to necessarily give companies access to the entire user's endpoint data. So making sure the endpoint data these apps or agents see is just a synthetic version of your usage data is another one. It's sort of back to the analogy of teach them about behaviors, not about the person. Because ultimately what you don't want is this person to know Tobias. You want it to be able to help Tobias. And then there are some some really interesting ones we've seen about simulating, for example, or creating diversity in what like toxicity language looks like, so they can be determined much sooner in gaming forums and environments like that. Because what we found is synthetic data is really good when you put a model into production and that model comes across a new pattern that it has never seen. What happens is that model drifts off course. And in a lot of the cases now you have to take that model, find that new pattern, train it on it again, and then load it, which this sort of drift has enormous costs, especially if you think about it in the cases of health or fraud. Synthetic data is very good to basically see that small sample data set, generate more of it, quickly retrain the model to prevent that drift. So that has been another cycle. And then one last one that we particularly found interesting is that some financial institutions or hedge funds using it to create these like black swan events in their data just to stress test their systems and see when they tip over. I think they're all trying to figure out, how do I prevent myself from becoming like the GameStop sort of receiver end of these types of things. And that sort of what if scenario that you can prompt into your data using synthetics generated with language models is actually quite powerful for that, where you can generate scenarios and see how your systems respond to it.
Yeah, I can definitely imagine that being very useful, particularly if you're saying, I want to enter some new product area. We don't have any prior experience actually with working with those consumers or that particular industry or vertical. So now I'm going to generate a bunch of data that looks like something from that area so that I can see how my systems are able to actually work with that and some of the different engineering effort that I need to do to be able to prepare for that before we actually launch and decide and find out that we're actually just going to fall over.
No, 100%. It's actually a really interesting point. We have a blog about this that we wrote. So back to the language models, sort of deep structural stability and understanding of your data. We actually have customers where they use this, for example, for consumer goods and predicting sales, where they might have a lot of data for a particular region, like let's say San Diego. This is a real blog we have about San Diego at a particular time of the year. And they're trying to say, well, if I were to sell the same goods in Tokyo at this time of the year, what would be the response? So they use their own data as a seed, but because agentic and language models are good at understanding contextual behavior of how people operate in Japan, what do they typically buy, what do the seasons look like, those two things merge actually can make these types of predictions that turned out to be incredibly accurate. So it is a way where we sort of describe, we actually have this term we use for it is that reducing economics for data acquisition. Like if you're building a new service, if you're Uber and launching into a new city, you might have to go there 6 months and learn, to your point, all the pitfalls, versus at least like starting 90% good enough and figuring out the last mile versus the whole 10 miles.
And in your experience of building Gretel, working in this space of synthetic data generation and its application to different data and AI systems, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Man, challenges. It's like infinite and non-ending. So I think the biggest learning lesson in the last 4 years working in the AI space has been, how do you continuously build product market fit? Because it feels like every 6 months you need to adjust for product market fit because of how things change, from deployments to implementation to even pricing strategies. So that's one. The second part of it is the war for talent is real. Majority of the new techniques or types of tooling and work that is being done is, there aren't folks that have more than a handful of years of experience, and most people have no experience. So sort of not only bringing talent, but when you build talent, you're investing a lot of knowledge and inherent sort of value into them, and then retaining talent. So talent is a real critical sort of tentpole of this whole thing. The other part of it is, there is, like most industries at sort of nascent emerging space, there is a lot of gap in industry knowledge for what good means. What is good data? What is private enough data? What does it mean for me to perform well? Like all these types of questions that for enterprises to bet millions, not tens of thousands of dollars on a product or a platform, need better answers and more clear answers. So the validation process for a lot of those types of challenges to commercially validate and prove something with enterprises is not very repeatable yet. There's a lot of white glove sort of services component that needs to come with it. So I would say that the thing that all this collapses into is that real enterprise, sort of outside the chatbot level, that real enterprise repeatability motions that can be consolidated and then asymmetrically scaled. Those are sort of at the core of all the challenges we tend to see, and I've been experiencing sort of front lines.
And what are the cases where the use of synthetic data is the wrong choice, or maybe you just need to have a Python dictionary that you're using, something like Faker, to just spew a bunch of data into, and that's good enough, and you don't necessarily need to reach for the industrial strength language model to generate a whole large volume of various data types?
Yeah, so if you're doing QA and test, you're measuring TCP packets, or is this thing going to get DDoSed if I get this amount of traffic? You don't need our system. It's just overly expensive to try to do that. It's like trying to use a laser to light a cigarette or something like that. There's much easier ways. But I would say those where the quality, the privacy, the utility, it's not critical. It's not paramount. It's just the volume of data you need that you just don't have otherwise. Those are things that are overkill for our approach, or using language models of sort of any kind for that approach. It's just overly expensive. The other side of it is any data that needs to be reverted back to its original. So let's say you're doing drug trials and you want to, for example, have thousands of patients, you collect their data, you want to do some analytics, you want to make some predictions, but you need to take that data and reverse it back and say, like, all these things happen, all these predictions were made. If I go back to the user, or to the patient in this case, did the outcome match my predictions? So there are ways to do that with synthetic data, but ultimately synthetic data is meant to sort of be privacy preserving in that sense. So those use cases that are two-way doors maybe are a better fit for anonymization, de-identification, transformation, versus going full differentially private synthetics. Like, our approach at that level is a one-way door. I want to be able to train a model, fine-tune a model, potentially share my data with somebody else, not be worried about compliance. And in some cases, we're even talking to customers who are like trying to monetize or sell their data in that way. So it's about, like, do you want it to be a one-way door or a two-way door that defines, what level or type of synthetic data is the best option for you?
And as you continue to build and invest in this space and keep tabs on the evolution of the AI ecosystem, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore and invest in?
There are a few categories. One, the biggest category we are focused on is, it may not sound terribly exciting, but it's actually like enterprise readiness that we're focusing on. So over the last, little while, we've been focusing a little bit more on making our product easier to use with native integration. So we spent the last quarter roughly building a lot of native operational integrations into the entire stack of Azure, into AWS, and in some in sort of other platforms as well. That has been very promising because we see now customers coming faster, transacting faster, contracting faster, moving through the pipeline faster. The other areas that we're super excited about are some new privacy techniques that we've been looking at that enable the same level of mathematically provable output of the data, but they have significantly less overhead as far as computational costs go compared to differential privacy. So there are sort of better techniques you can use there. We are also starting to see much better evaluation frameworks where it allows us to be able to build domain-specific or task-specific models much faster with sort of better guaranteed outcomes. I guess the area that I'm sort of particularly, super interested in is the techniques that we are starting to implement into synthetics, like reflection. So you can take a system like ours and generate synthetic data that can teach any open source model to reason, like an O1 model. Now, not quite at that level yet and not quite at that scale yet, but we are actually demonstrating some of that early steps of that being able to do this. We wrote some blogs about it showing actually some better outcomes than some comparable models that were trained using traditional techniques out there. But that to me is very interesting, because if we can enable most customers to just be able to adopt a synthetic platform and using their data teach a model to reason about their data, not generically reason, that is a very powerful tool to open, especially if we think about like individual researchers or small organizations, folks who don't necessarily have that level of expertise or resources. That is a very democratizing approach to sort of leveling up everyone's capabilities.
And are there any other aspects of synthetic data generation, the work that you're doing at Gretel, and the application of this source of data to AI systems that we didn't discuss yet that you'd like to cover before we close out the show?
I guess the one area I would sort of talk about is how governance and policy is starting to impact some of this. So one of the things that we hear quite a bit from our customers, one of the reasons a lot of our enterprise customers look at synthetic data from a sort of an adoption standpoint is their view is that, like, if I'm in a regulated industry, if I forward 5 years, if I'm a CIO or CTO or CSO, I'm worried that I'm going to have to deal with hundreds of compliances and regulations from my industry, from my state, from my country, from my region. If I'm in the EU, like 15 different ways it's going to apply to me. So I can't be on this treadmill of like every month there's a new regulation and I have to go retroactively check and forward check and validate. So synthetic data helps with some of that. But I actually think that the more interesting part of it is how do you apply some of these things more ubiquitously? Like, as we know, there's regulations that California, Texas, Utah are trying to pass for, AI ethics and governance and best practices. Frankly, things like this at the state level are a terrible idea. Like, you don't want to have encryption standards that are across, hundreds of countries and dozens and dozens of states, right? Like, these are the types of regulations, policies, and protocols you want very much standardized. So I think the most interesting part of it that is maybe non-interesting technically is there does need to be a push for regulation and some policies around privacy in data. And synthetic data is just a subset of that, but data that is used in these environments and how that should be controlled, how it should be managed so it's sustainable, because I think the current approach is not a sustainable approach to data usage. Essentially, it feels like AI, in a way, is taking what social networks did at the beginning, which is the user was the product they were selling to advertisers. AI is sort of doing that with your data to basically sell to other users. So there needs to be a more sustainable approach, and I think there is room for policy and regulation to help with that.
Yeah, that's definitely a very valid insight, and one that I think we should all be thinking about as we continue to iterate on these systems and build them out. Is what is the actual model that is sustainable both economically and ethically and kind of in a societal factor as well, particularly in light of some of the recent insights that we've gotten into OpenAI's pricing model. All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
I think the biggest gap right now is around evaluating model outcomes, evaluating data, evaluating quality. So it is really the gap I see that takes us from training, pre-training, customization to serving inference time compute. It's that chasm we're trying to cross right now. And the biggest question is really around all these aspects of quality and good looks like and abundance looks like. And it is very unclear. And that is one of the areas we're chipping away at because it sort of contributes to everybody's success. But I think that is one of the pieces left that, if solved for, can really accelerate adoption and measure of value for these AI tools.
Well, thank you very much for taking the time today to join me and share your experiences and your expertise in the space of synthetic data generation and ways that we can apply it to AI systems. It's definitely a very interesting and important problem area. So I appreciate all the time and energy that you and your team are putting into making that more tractable and available for the people that need that. And I hope you enjoy the rest of your day.
Yeah, thanks for having me. I appreciate the time.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.